Hello everyone, in this video we will learn how to find the sum of this challenging series. I'm going to let this one be a sub n, right? Now I'm going to start with the denominator. So I have n plus 1 factorial plus n factorial. This one can be written as n plus 1 times n factorial plus n factorial, right? I'm going to factor n factorial out, so I have n plus 1, right? It's going to be n factorial times n plus 2, right? So a sub n becomes n over n factorial times n plus 2. I'm going to multiply the top and bottom by n plus 1. So then I can convert the bottom into n plus 2 factorial, right? And the top becomes n squared plus n, right? Now this one can be written as n squared over n plus 2 factorial. Now n right here can be split into 3n subtract 2n, right? Then I'm going to add 2. And then I subtract 2 right here, right? Now, negative 2 right here can be written as negative 4 plus 2, right? Alright, so I can separate this guy into 3 fractions. The first one is going to be this guy, right? I factor n squared plus 3n plus 2 is going to be n plus 1 times n plus 2 over n plus 2 factorial, right? The second one right here, I just factor negative 2l for this guy right here. So I have negative 2 times n plus 2 over n plus 2 factorial, right? And the last one, I have 2 over n plus 2 factorial, right? Now I'm going to put the summation notation in front of each of this one, right? Now we're going to simplify the first one. N plus 2 factorial can be written as n plus 2 times n plus 1 times n factorial, right? So this guy and this guy cancel out, this guy and this guy cancel out. I have the sum n start from 0 to infinity of 1 over n factorial, right? Now the second one right here can be written as negative 2 times the sum 1 over n plus 1 factorial, right? And the third one is going to be plus 2 times the series 1 over n plus 2 factorial, right? Now I'm going to call this one A, this is B, and this is C, right? So A equals the series 1 over n factorial when n starts from 0 to infinity. This guy actually E, right? Remember we have the Taylor series for e to the s. It's going to be the sum n start from 0 to infinity of s to the n over n factorial. And this guy actually E for s equals 1, right? Now B is going to be negative 2 times the series 1 over n plus 1 factorial when n starts from 0 to infinity. Now we just shift the index, right? So we let m be n plus 1. Then b equals negative 2 times the series m start from 1 to infinity of 1 over m factorial. And it's going to be negative 2 times 1 over 1 factorial plus 1 over 2 factorial plus etc. Right? And it's going to be negative 2 times e minus 1, right? Which is the one on the top right here. But the top right here and start from 0, this is start from 1, right? So you need to subtract 1 both sides, right? For C, it's gonna be 2 times the series and start from 0 to infinity of 1 over n plus 2 factorial. And C similar to B, right? We're gonna shift the index, right? We're gonna let m b n plus 2, right? So C becomes 2 times the series m start from 2 to infinity 1 over m factorial, and it's gonna be 2 times 1 over 2 factorial plus 1 over 3 factorial plus etc, right? And this guy actually e to the s, where you're gonna subtract the first two terms both sides, right? So this guy turns out to be 2 times e minus 1, right? And it's gonna be 2 times e minus 2, right? Now finally, the original one right here equals a equals e right here, plus b equals negative 2 times e minus 1, right? And plus c for this one. Now we're going to simplify this one, so it's going to be e minus 2e plus 2 plus 2e minus 4, right? So it's going to be e minus 2, right? This one is the final answer, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in